Hello and welcome to another edition of Science Magazine. In today's magazine, let's first listen to an interview on green hydrogen in the perspective of the Indian economy. Interviewer is Kaushik Roy.
We are extremely privileged to have in the studios today Dr. R.K. Kotnala, Chief Editor, Current Natural Sciences and Engineering, and also a very distinguished academician and a patent holder of many patents. Thank you for gracing our studios, Dr. Kotnala. Today we are going to discuss about the green hydrogen from the perspective of Indian economy. So first of all, what is this green hydrogen?
Green hydrogen is nowadays a buzzword. It is produced by the water splitting, and in the water splitting, when hydrogen is being produced, that is the way where we can find out it's a highly pure.
So what are the uses of this green hydrogen? And today, as you rightly said, it is the buzzword, and many countries are investing a lot in green hydrogen. Lots of research is going on. What would be the uses of this, and is it clean? Because that is where everyone is concerned about.
Your question is definitely very important because it is the cleanest fuel, and the cleanest fuel means while hydrogen is being used as wherever the fuel, as it reacts with the oxygen, so H2 plus O2 results into the water vapors initially, right? So that means there is no other carbon dioxide gas, greenhouse gases emission with it, and there is no residue left.
And another thing is that what is the scope and future of this green hydrogen? Here also I'd like to ask you, Dr. Kotnala, that India set up the National Hydrogen Mission also a couple of years back. So your take on that?
As far as when we say that what's the use of it, where it is to be used, hydrogen is needed in general for the industry, for the fuel purposes, for transportation also. Means rather than a crude oil what we are using as a fuel nowadays, so we'll use the hydrogen. In the cars, we are going to use hydrogen only to run the car. And not only on this, there are the other big industries where a lot of consumption of the electricity happens. That is also replaced by the hydrogen.
And what will be the cost factor in comparison to traditional electricity and traditional fuel?
In comparison to the traditional electricity and even our petrol or diesel fuel, what we are finding that it is at the moment quite expensive. And quite expensive in the sense that it comes into the range of $5 to $8. And we know very well that around $1 you get the petrol, diesel, not only here but internationally also. And this is one of the point. The other point is the establishment of producing the hydrogen through the machinery, through the plants. That itself is a challenge at the moment, and the people are trying to overcome that.
So what are these challenges, and how do you think that it needs to be tackled?
Challenges on this, how to produce the hydrogen. So the first is the different methods are available. One is that we are just burning the fossil fuel, and with that fossil fuel, if we are putting into the steam, so it's a very traditional industrial method where we get known as a steam gas, and the hydrogen is there, and which is used as the fuel. But that is a very impure. Very impure in the sense it also produces a carbon dioxide.
Yes.
And carbon dioxide we are not interested to get, because that is for our, whether we call it a climate change, global warming, and even for us to have the breathing, and as well as the particulate matters are being emitted out of it. So this is the challenge. Normally it is called a grey hydrogen, but the people have gone to the blue hydrogen where they said, okay, whatever the carbon content, which is called normally the decarbonization, that will be there. Then what we are going to do that, all the carbon dioxide and the carbon content can be absorbed, or we should use the other way. That carbon content, if they are removed in the process of that, then that is called blue hydrogen.
Right.
But when we say the green hydrogen, then the objective is the only one, that we are using electrolyzer. If you will be knowing, earlier, even the 300 years before, in the water, they put a little acid into it and just a very high electric current and voltage is applied through the electrodes, and we get a hydrogen and oxygen on the respective electrodes. So that is the process of the electrolyzer. But nowadays it has been improved, refined so much during the last 2 decades that this electrolyzer can produce the electricity. But the problem is that it consumes a lot of energy. So that to run it, because electrolysis is a process when you are applying the electricity on it. The water is split into the hydrogen and oxygen.
Yes.
And how to separate them out, then catalysts are used, then a lot of chemicals are used into it, which are, toxic for us also. So those all are to be, avoided. In which way can be done? For the electricity all over the world, it was realized that why not to use our renewable energy sources like a solar cell. Solar panel is used because the electricity will not produce, but the solar panel will be using, and those solar panel will be providing the electricity to the electrolyzer, and then you get your hydrogen. And they think of wind energy, then other renewable sources, but those are, I'll say their quantity is very little and intermittent, means not a continuous supply, but the solar panels are able to do it. So that's one of the challenge, that how to get high purity hydrogen. It's a green hydrogen because you are not emitting any greenhouse gas.
Right. Another factor, Dr. Kotnala, is that we have spoken about green hydrogen and how good it is. How is the safety aspect of the green hydrogen?
Safety aspect, whether it's a green hydrogen or is a grey hydrogen, is the same. But we take care, because the hydrogen, everybody knows that if it is by chance exploded by some kind of a error, or it comes in contact with the oxygen directly, then also without a controlled manner, then what is happening? Again, explosion occurs. So the safety aspect of that is very important, that how to use it, like in our gas stoves, LPG, what we are using at home. Then how we have to control the LPG control, and the oxygen means the air is coming into it, because their oxygen is being taken from the air. So that control. Then another safety aspect comes, that when we have to transport, like you may be knowing, LPG gas, which is filled in our cylinders. And those cylinders are compressed with a very high pressure, and CNG is now at that stage is in a liquid form. But when we use it, then it directly comes because at a room temperature it is a gas. Then the compression is done under high pressure. That is why the cylinder is also, LPG cylinder is very heavy, because it has to withstand that pressure. But the temperature of hydrogen goes near the 0 Kelvin, means it's around 4 Kelvin, and we all know that all air is liquefied around 90 Kelvin, and we are going below that. Below that means the 4 Kelvin. So there is a lot of compression. Then the other safety aspect, because it will be put into the liquid form and then transported here, there, and used.
So, do you think these are the challenges, and how do we overcome this? What are the works that are going on at present to overcome these challenges?
A lot of work has been already done in the Western countries, Europe. They have done the different types of the engineering and innovations, that the new type electrolyzer will be there. Then even the compression of the gas is to be done. How? So that compression of the hydrogen in a liquid form. So that technology is already available, but it is expensive. So is the case of the electrolyzer when we want. Because in this electrolyzer, whenever we are in general electrolysis, we say the water is there and we are splitting it into H2 and O2 finally. But in the electrode, we are using a lot of catalysts, and catalysts are very expensive. Platinum, cobalt, and others, and they add a lot of cost, because they are not being used for a long time, very long time. They get poisoned, because in any of the reactions the catalysts are poisoned also. So it is the situation here also. So a lot of work has been done. In India also some efforts are being done. National Hydrogen Mission has come up, and the government is supporting that how to move ahead, because we wish to have clean energy, because it's the cleanest fuel, and it is a need of the hour in terms. The reason being, the hydrogen is to be used in all different fuel we have to replace.
Right.
Which we are using at the moment.
Yes, and of course it's a known fact that the petroleum reserves or the what we call the fossil fuels, they are also not going to last forever. So the focus is now on biofuels, on renewables and green energy, using the wider term, which includes electricity and fuel and fuel for transport and all that.
Yeah.
Dr. Kotnala, very important issue you have taken up today is the green hydrogen, and can it contribute to the sustainable development goals of the United Nations?
Sustainable development goals of the United Nations are required for the overall the health of the, I'll say, the earth and as well as we human beings.
Yes.
Both have to be taken up. And once a green hydrogen comes, just I'll give you a very small example, that in Switzerland already the plant is working for producing a green steel. And in this one, there are the two things. One is hydrogen is being used as a reducing agent for the iron oxide to convert into iron, so that it can be changed to the steel. Then not only the reduction, because normally that reduction is being done by the coal. The coal is being used and lot of carbon dioxide is being
emitted into
the atmosphere for reducing our iron oxide into iron. And India is the largest producer for the all iron minerals, particularly on this steel and all. And they have already done that part. And also the temperature of the blast is needed to be kept around 1600 degrees C. And to maintain 1600 degrees C for the 100 tons at one time, how big is the blast furnace?
Yes, we can well imagine.
It itself is a big building, right? So in that case, the lot of fuel, earlier coal burning was being used, crude oil burning. Later on, they have changed to the nowadays with the gas also. But all gases, the gas I mean to say our LPG or any other gas, they produce the carbon dioxide and other CHG, and even the NOx is also produced. So all that has been replaced by only hydrogen. Hydrogen is being used as a fuel and as a reducing agent for the iron to produce the steel, and the steel is now green. And this is the only specialty needed because it is one of the biggest, I'll say, that energy guzzler. So they are working fine because they had established in 3 years before, and now it is giving a production. So they are issuing the sound the result. Similar things like in India, we have to change some of the industries. Not only in this fertilizer. In the fertilizer, we are using ammonia a lot. And the ammonia is to be produced. So while the ammonia is being produced, so that is a hydrogen.
Right.
We
on that note, Dr. Kotnala, the final word from you on the future of green hydrogen production.
The future of green hydrogen production is the one is the electrolyzer. But the biggest invention of the world of the 21st century in green energy domain is hydroelectric cell, for which the inventor, myself and my colleague Dr. Jyotisa, we have already innovated a hydrogen reactor in a lab where we have produced even the 18 liters, 20 liters green hydrogen, which is highly pure, 99.98%.
That's wonderful to hear. Dr. R.K. Kotnala, thank you so very much for joining us in the studios today and sharing your thoughts on this fuel of the future, that is green hydrogen. Thank you very much indeed.
Thank you very much, Kaushik.
You were listening to an interview with Dr. Ravindra Kumar Kotnala, Chief Editor, CNS&E Journal, and former Chief Scientist and Head, Environmental Sciences and Biomedical Metrology Division, CSIR-National Physical Laboratory, New Delhi. And the topic was Green Hydrogen in the Perspective of Indian Economy. Interviewer was Kaushik Roy. With this, we come to the end of today's Science Magazine program. Narrated by Nitish Arora and produced by Dilip Jha, this broadcast came to you from the Indraprastha channel of Akashvani, Delhi.